Hello, I'm Nobby Clark, welcome to my workshop. I've got another little project I want to start. In a second I'll bring you in a little bit closer to the bench and show you what I'm going to try and make. This is probably going to be one of those one-day projects that takes me at least 3 days to make, like everything else seems to. So bear with me just a moment and I'll just bring the camera position in a little bit closer for you. I've made a number of chamfering tools over the years. The first one I ever made was this one, which I made for my Chinese mini lathe. So this was probably made in 2016, I guess, after I'd got the lathe. And it's just basically a piece of 1/4 inch square tool steel, which I ground on both sides to a 45-degree angle. Hang on just a minute. A visitor's just come in the workshop to see me. It's my cat. She likes to come in occasionally just to see what I'm doing, so I think I must do her the courtesy of showing her off. She's having a good look around. She's saluting the flag, aren't you? Hey? Yeah, I know. Yeah, it's nice warm weather. She spends a lot of her time outside now. Aren't you? You're going to get down so I can finish making my video, are you? Hey? Let me put you down. Hang on a sec. Yeah, off you go, mate. There we are. Well, sorry about that. Not often I get many visitors in the workshop, but there we are. Anyway, where was I? Anyway, so this is one that I made for the Chinese mini lathe. I only made this one with the chamfering end on one end of the material. I should really have made it on the other side as well, so that it can be used that way or that way on the tool post. So when I got the Myford lathe, I made another one, and I did make this one with the 45-degree angles on both ends, so that it can be used in the conventional on the tool post and on the other side, where you would, I suppose, normally put a boring bar. And a short while ago I actually showed, I think, the video on this one. I made one using some carbide tips, and again, this was very easy to make. It was just a matter of machining out a little section here with a shoulder, so I could have one of these tips on each end, and I use this one quite often as well. But what I wanted to do is to make one using smaller carbide tips. I got a pack of these tiny tips the other day. These are fairly standard ones that I use a lot of the time on my lathe tools. So I'm going to make a holder for these. I've got a piece of 3/8 square material. It's the odd thing about the Myford is that you've got a limit on the size of material you can use, because if you use material that's too big that would actually fill this slot here, you can't centre it up, so you are a bit limited, I think, to sort of around about 10mm square. I think this was probably, yeah, that was the same size material as this, in fact. So I've marked out both ends. I played around with this to find the angles, which I think are 40 degrees. So I've marked the angles out on here, and the little spot here on this end I've already drilled out. So what I need to do is really machine all of this part out up to those lines on each side. So I'm hoping if I can find a small enough cutter that I can run the cutter across into this hole here, so that will seat into it, so that will drop into the hole, and then I can drill and tap in the centre here for the little locking screw. I have got a little pack of spare screws, because it's one of those things that when you're changing these tips over, it's so tiny, the screws are, you can very easily drop them. Although so far I haven't dropped one. Probably will now I've said that. So anyway, that's going to be the first, well, the first job was actually drilling the hole. But what I've got to do is find some way of setting this up on the milling machine, so that I can easily cut these angles. And I think I've come up with hopefully quite an interesting way of doing it. So I'm going to set that up and show you what I'm actually proposing to do. So bear with me, I'll come back to you. Before I go ahead with the project itself, I just wanted to say a big thank you to all the viewers and subscribers to my channel. It's due to all of your support that it's given me the reason really to carry on with these little videos, and also during the last week, on the 4th of July, a number of things have happened. Basically, it's the general election in the UK. In America, 4th of July, the American Independence Day, and also the 2nd anniversary of Nobby's Workshop. I can't really believe that my YouTube channel has been going for 2 years now, and this video is the 111th video I've produced so far. And it's all due to you. Without you obviously watching my videos, there'd be no reason for it at all, and it's helped me along the way a huge amount, particularly the comments you've made to my channel, and given me a means of communicating with other YouTubers. Although out of all the people that have watched my channel, I've only ever met 2 of you, but I feel that I've met all the others. You know, I've got people watching my channel from all over the world, which is really wonderful. Around Europe, America, Australia. This is absolutely brilliant that I'm communicating with people all around the world, and getting sort of help and advice from a lot of them as well. So with that said, thank you so much again, and let's get on with it now. Well, this is how I thought I would set it up, using my fixture plate. I thought, well, I've got the fixture plate, let's use it for this job. So what I've done, very simple, I've got a couple of dowel pins in here, and I've put a 30 and 10 degree angle setup block in here, and I've set the workpiece against that, held it in very firmly in position, and clamped it into place, so that I can then remove these, and I can put another toe clamp on here somewhere, so I've got a number of positions holding this so that it can't move. And just to check that this is going to be square to the milling machine, if I put the 1, 2, 3 block at the back and then bring a set square in, hold that in position, it lines up perfectly with the scribed line on here. So on the milling machine, all I really need to do is to find a small enough cutter, is just run the cutter across here and bring that sort of machine that part out and until I get it down to the depth I need, equal to the thickness of the carbide tip, and then just swing that round in exactly the same way to machine that side as well, and hopefully that's going to work. What I will need to do, in fact what I did with with this one that I made, when I'd got this set up, this was easier to set up because this was in the mill vise and I was just machining across here. But what I needed to do, when I'd got them both near to the right depth, was to run the cutter across and then move the cutter round and across here, so that the step here is exactly the same height on both sides, so that once I've set this for the centre height on the lathe, the one on this side will be exactly the same as well. So I need to do the same with this as well. So without removing this from the milling machine vise, to do the same, so that everything is going to be perfectly equal on both ends. So the centre height setup is only required once then. So I'm going to hope this works. I'm sure there's many other ways of doing this. I guess it could be done on the rotary table, and this could be attached to the rotary table in some way and then swung round to get this in the correct position. But I think in terms of the time of setup, this is going to be the easier way of doing it, I think. Anyway, we'll see how we get on. Obviously I'll bring you back for some of this. I'll probably cut one end first off camera just to make sure everything's working and in place, and then perhaps bring you back for when I cut the other end. Just very quickly, this is just to show the actual setup that I'm going to use on the milling machine. I've put my other vise back on the milling machine here. This is the vise that I used to use. This is so like a tool maker's vise, and I used this for a very long time, for quite a number of years. It's if anything rather slow to set up, to get the jaw in the various positions. So if you're familiar with how this type of vise works, you'll probably understand what I mean. But then when I got the other vise here a few years back, I switched over to using this one. This is it's an import vise, but it's an Acculock type, so it does hold the working position very easily. I've had to use this vise because on the vise I'm using most of the time, the jaws don't open up enough to take the width of this plate, but this one does. In fact, the jaws will open even wider. So I've mounted this on the bed of the mill, and I've clocked the edge in here very carefully, and I already know from when I'd made the fixture plate that the positions for the dowel pins are all perfectly square to the back of the fixture plate here, so that this gives me on the fixture plate a good datum here, so everything will be nice and square, so I shouldn't have any problems with it at all. Obviously I've got to break this down again before I start work on it, because obviously I want to drill this sort of clearance hole at this end first, so I'm sort of ready to start doing the machining work. But that probably will be on day 2. I start doing this on my 1-day project. Anyway, I'll bring you back for perhaps cutting one end, or so you can see a little bit of the machining anyway. I'm setting up now to cut the little V shape in the piece of material. I already showed you how I have set this up on my fixture plate using angle setup blocks in here to give me the 40-degree angle on each side at the end here, and I've locked this in very firmly with 3 toe clamps, and I've clamped them down really tight so that hopefully it won't move while I'm machining this out. In the mill vise here, I'm using my older vise here, the machinist vise, and I'm mounting this on a couple of parallels, and you see I've used a bigger piece of that spring material that was kindly sent to me, just to hold the parallels apart while I get this in position. I just cut a section of it out and just sort of bend it round. There's enough pressure on that to hold these parallels against the sides, so that will drop in here. I try and get the area I'm cutting as near to the centre as possible, and then lock the vise. When I got this, it just came with a regular Allen key, but I made a slightly better T-wrench to lock it down, just using a bit of an Allen key in here just to get a bit more pressure on it to lock it in. Difficult thing of sort of knocking this down, I just sort of simply used a piece of brass hex and then just sort of tap that down just to make sure it's seated well in position. So that's locked in nice and tightly. I'm going to use a 1/4 inch cutter to cut these little bits out here. Just going to bring you in a bit closer so you can see that a little bit better. There we are. I've already done one end, basically just to sort of test everything out first, and I've got a nice fit for the tip. Fits in really well, so I'm hoping I can get the other end as good as this. So obviously once that's positioned, I've still got then to take out these corners here, but I'm going to do that as I did before on probably on the belt sander, to grind these corners out and sort of shape them down to give me clearance for the cutting tip. But that will be probably the last job to do. What I'll need to do before that obviously is drill and tap a hole in here, in the part here, to hold the little cutting tip in place. So I'm just going to set up now, ready to machine these parts out. I'll try and show a bit of it, although it took me a long time to machine this one out, because I took things obviously very, very slowly while I was doing it. And the difficult thing obviously was accurately setting the end mill to be exactly on the little scribe lines here. Obviously I do one side first, and then reset this up, swinging it round this way. It obviously leaves then a little triangle on the end here, but what I did with this one, I just use a bigger cutter to machine that down to make the whole thing level in here. Right, so I'll get set up and just bring you back just for a little bit of this. So it's going to be rather difficult to get the camera in sort of close enough to this, I think. I'll try and record a bit of this. I've got the cutter lined up with the little scribe line here, and I've turned the cutter around by hand to see if I can line it up with one of the flutes of the end mill here, which I hope is going to be okay. Important thing here obviously is going to be use very light cuts and use plenty of cutting oil as well. I hope this is reasonably clear. I've had to turn one of the little lights out on the milling machine because it was causing a sort of a shimmering effect. Whether that is just what I could see on the screen or whether that will record, and I don't know, but hopefully you can roughly see enough. I'll only show a little bit of this because this is going to be a slow process and take me quite a long time to do, but at least I'll give you an idea basically of what I'm doing here. Well, hopefully that'll give you sort of an idea of how I'm approaching this. I'll just carry on with this now because, as I say, it will take me quite a while to do this operation anyway. If there's anything else I can bring you back for a bit later on, I will, but there's obviously still a few things to do to this lathe tool before it's completed anyway. The final part of the machining here is once I've cut out the V shape in here, is to remove this little triangle here that's left. I've changed the cutters over, put in a 10mm cutter, and which is just about enough to sort of machine that out without touching anything else, and then just machine that little section out as I did here on this piece, just to take that little part out. Again, I'll just show the sort of start of this for you. Just bring that down until we get it to touch off. again I'll bring you back when that's nearly complete. That's fine. So hopefully the little cutter will drop in there nicely. Lovely. That's it, isn't it? I can still see a bit of a scribe line here, and that's centering up quite nice, so quite pleased on how that's come out. So I can break all this down there, and I think the next thing will be marking out the holes to drill and tap for the little retaining screws that go in there. It's lovely. I'm quite pleased with how that's come out. So just give this a nice clean up now. There's a little bit of deburring to do, not too bad actually, and then I'll mark out where the little holes will be drilled to tap for the tiny little locking screws to go in there. I think they're about 2.5mm screws, quite small, and little torque screws. And then we're down to the part of grinding the clearance angles around that part. Then what I'll probably do is use an old carbide tip in there, use that as a sort of a guide so that I don't damage that one. This is an old worn one, to give me the right angles to grind that down. I think that's how I did it before, and set you know, some nice clearance angle on that. Excellent. My next job is to drill and tap the holes in both ends here to take the carbide insert. The way I'm approaching this is, what I've done is, to start off, I've put a scribe line through the dead centre here. Obviously I've blued this up, put a scribe line through the centre here at both ends, and I'm using putting the insert in, and then I found the size of screw that goes in. This is 2.5mm, but the hole in here is larger than that. So what I've done, I've found a drill which is a reasonably, not a tight fit, but a nice close fit through the hole here. And this turns, well, this is actually a 2.8mm drill. So what I've done is push the insert in as tightly as I can, and then put the drill in a little pin vise. Sorry, I keep disappearing out of the camera view here. In a pin vise, and then just marked up a tiny little witness mark in the centre there, and obviously I'll do the same at the other end of the tool as well. But there's also not a problem, but if you look at any commercially made tools, what you'll probably notice when you start to put the carbide into position to put the screw through into the thread here, you'll notice that the threaded hole is not exactly in the centre of the hole in the carbide tip. It's a fraction in this direction. So what I'll need to do is, when I set this up in the milling vise, I'll use a tiny pointer in the drill chuck to line this up very carefully, but then I'll move the pointer across just very, very slightly. I think the idea obviously is that when you put this in, the top of the insert has got a slight chamfer, and they are actually, or countersink rather, and the little screws that go in have got a sort of a slight countersink to them. And I think by having the tapped hole slightly further across, not into the dead centre, when you screw that in tightly, it pulls the insert back into position, so it locks it more firmly back here. So I'm going to do that. I'm only going to move it over, so it's going to be a bit of a guesswork on how far to move it over, but I think it only needs to be at the tiniest few thousandths across, and that hopefully then will seat the carbide tip nicely into place. So I've got to tap this 2.5mm. This is obviously rather dicey because the 2.5mm tap is tiny, and I only have two of these taps, but I checked them out. I think I must have bought both of these at different times. The one I'm using is not this one, it's the second one I have, which actually is a high-speed steel one, so I'm going to use that, because that obviously is going to be a bit tougher than a regular tap. So I'll use the other one I've got, and I'll need to drill this out. 2.1mm is the tapping drill size. Obviously I've checked various bits of information I've got to work out what the tap size is, and when I do use one of these, which I suppose you've seen these, the Zeus guide of sort of engineering information, this is a bit of a scruffy one. I found this, I think, at a exhibition I went to. It was obviously very, well, 1970 edition, but this one is the metric version, so it has all the same information that the standard version of this has, but it does have all the isometric threads as well. This will tell you that it's a 2.05 tapping drill, which I don't have. So I'll also refer to this other guide I use, but this one gives it for the two different TPI sizes for 2.5. It shows them both as being 2.1, so I'm going to go for that. Obviously, being that fraction larger probably is going to help the tap as well. You see, I've marked this. I've got fixed on the wall of the workshop near to the milling machine. I've got 2 or 3 of these that I've laminated, and on these I've marked out a lot of the common sizes that I use, just to get the reference to them quickly, because in a lot of cases, with in fact most of these, there are different TPI sizes for a lot of the different tap sizes here. You see if you've got a 5mm, that can either be 0.8 or 0.5, so you've got to make sure that you're choosing the correct one, although in a lot of circumstances in some circumstances the tapping drill size is the same for both, so it doesn't always matter too much, but it's a useful thing to have and keep this sort of handy. Obviously there's lots of different books you can refer to. I've got several books that have all this information in them, but it's nice to have this that arm's reach all the time. So I'm going to now move over to the milling machine, and or once I've marked this end out as well, move over to the milling machine and drill and tap these holes in place. Right, well I'm all set up to drill the first hole. I've made sure that the workpiece is over the edge of the vise here so that I don't drill through the parallels, and I've used my little pointer to line up with a little mark I made and then just move it inwards slightly. I don't really know by how much, it's a bit of guesswork, so I'm just hoping it's going to work okay. I didn't film that part of it because I just took my time lining that up as best as I possibly could, using obviously a little magnifier to help me. So I'll make a little marking that with a centre drill, just to hopefully guide the drill incorrectly into place. So hopefully that's enough, but it's not a very big drill going in here. I'll put the 2.1mm drill in. Just cutting oil, plenty of cutting oil on. Oh, flooded it. Never mind, doesn't matter. Okay, just clean the mess off there. Take that out. What I'll do is I'll use the chuck to start the tap off, and then do the rest by hand. Sorry if my hands are in the way of putting this in the chuck. So switch the mill off so I don't make the mistake of turning it on while I'm doing this. Some cutting compound on the tap, plenty on. Give it the best chance. Possibly not in tight enough. very, very careful that I don't damage the tap. Hopefully that's going to be enough of a start. Quite firmly. Obviously this part of it I've got to be very, very careful. Seem to be going through okay. It's come through. I'm going to run that right the way down so that hopefully I'll form the thread really well. To run that down as far as that will go, and hope that that's done the job okay. And when these little taps, the 2.5mm ones, I have used these a number of times before. But I don't have a lot of, well, I don't have a lot of high-speed steel taps. Most of them are the much sort of cheaper ones. So if I've got that out okay. Right, so I've just got to remove that, give it a clean up, and see if I've got the thread in the right place. Hopefully it's going to be okay. Well, that appeared to work okay. I just deburred each side of the thread, the back as well, and I've put the insert in, and it does seat in really nicely, so I'm quite happy with that. And I've looked at this through a magnifier as well, and it's seated perfectly into that little sort of V slot there. So that's that part done. The final part now. Well, I've got to do the other end, obviously, but I'll do that one off camera, and then I've just got to grind off those sides there to give me a sort of a clearance angle. I've just got to work out what sort of angle I need. Don't think it needs to be very much at all, 6-7 degrees, something like that, but I'll work that out. So quite pleased with that. Something slightly off topic. Somebody asked me why I've got a bit of brown paper behind the mill here. Well, if I can move that out a bit more. Hang on, there we are. Basically, it's actually to stop swarf flying across here and getting all over the back of the mill column. What I originally had was this. It's well, I call this material leatherette. It's the sort of stuff that you can recover chairs with. So I put a plate on the back of it with magnets on it, and I used to hang that down the back. Problem was that it also gets covered in cutting oil as well, and the chips get stuck all over it, and it's just proving to be a bit of a problem to clean. So I use some paper which comes off large sort of paper delivery bags, so that when this gets filthy dirty, I just throw it away and put another piece on, similar on. So, Just have to be frugal, don't you, in what you do in the workshop sometimes. But anyway, for anyone that was ever interested why the bit of paper is creaking in the background, that's why. I'll just show a little bit of this. This is basically cutting the clearance angles on each side. So I put the carbide tip in and then just scribed lines on either side to guide me. The clearance angle was 7 degrees, so I've set the table here to a 7-degree angle in relation to the belt itself. Again, I'll only show a bit of this because this is really noisy, so and you're not going to easily be able to see what I'm doing anyway, but I'll just show a little bit of grinding and then you can just imagine the rest. Well, I'm sure that's enough for you. I've got the part mounted into a machinist clamp because obviously, and wearing stout leather gloves because obviously the part's going to get very hot. But I'll carry on with this and I'll just bring you back just to show you the finished result. There we are. With the Kobe belt sander does produce a nice job. So I've got my 70-degree angle there. This part is still very hot still. I'm just going to have to focus a bit. Oh yeah, back in focus again. And I've just rounded the tip off as well. Otherwise it would be a very sharp point. There's some just other little bits on the side that I'll just need to clean up with a file a bit so there's no sharp edges on it. But basically that's the part completed now. So I'll bring you back in a bit and just show you, let it cool down a bit first, and I'll show it to you again with the tips fitted. Kobe belt sander, very good. Well, that's the end of this little project now, and it's come out quite nicely. I've given it the part a good clean up, and mounted both of the tips in here, and I've got nice that Kobe belt sander does a really nice job. I've got some nice clearance angles all around, and I've just ground off the end of that to take the sharp edge off. But I'm quite pleased how it's come out, and I'm delighted. The end result only remains now is perhaps to give it a quick test to make sure it's working okay. What I will do is later on is cold blue it so I can get a protective finish to it. I'm going to do that a little bit later on because I'm trying to accumulate a number of items to do in one go. Sort of once I set up the cold bluing chemicals, I've got sort of 3 or 4 different things to treat in the cold blue solution now. So that's sort of it. In the background here is my I'd always try and do, as I mentioned, try and do a drawing of what I'm making with all the measurements and various notes to refer to all along, and I can add extra bits of information to it and just keep this on the bench to keep referring back to. Well, that's it from me again. Thank you very much for joining me in the workshop and watching me make this simple little double-ended tool holder. I've got quite a few projects already completed and lined up now, so I've got a few videos for the next few weeks. Again, this was I said this should have been a one-day project, but it's taken me about 4 days to do it because just recently the weather has been very warm, and in my metal workshop the temperatures have been getting up, I think, about 36-37 degrees during a couple of afternoons recently, which is it's just a little bit too hot for me to stay in the workshop comfortably. So what I'm doing is trying to get in the workshop in the mornings when it's a little bit cooler, but I think we've got some slightly cooler weather coming up, and I've got some other projects in mind as well for the future. So thank you for joining me, and thank you very much to all the subscribers to the channel and all the comments I'm receiving as well. I did tend to get quite a lot of comments from the same people to a lot of my videos. Same with me, I'm probably commenting to the same people all the time as well. Well, I do watch a lot of channels. It's something I can do in the evenings. I don't really watch hardly any television, so I quite like to watch what others are doing in the workshop because it's a learning experience for me as well. So I mean, if you have any comments, you know, please contact me through the comments. I'd love to hear from you, particularly anyone perhaps I've not heard of or heard from before. If you've got any questions for me, any help that you can give me or help that I can give you, although I'm not that experienced, but there we are. So that's it from me. I hope to have we'll have an interesting video for you next weekend as well. So thanks very much, and bye bye for now.